Hello everyone and welcome to Bez Repair Bench. Uh, Today's video I was hoping to introduce you to some SolidWorks design drawing this tugboat hull, but after a whole bunch of different tries and a whole bunch of technical difficulties and also realizing that this might be a little too complicated to teach some basics, I decided to backtrack and kind of change my tactics a little bit. So we're going to start something totally new, and we're actually going to design and model up a little pirogue. Now, for those of you not familiar, a pirogue is a little double-ended, flat-bottom boat, most often just paddled by hand. That is pretty prevalent in South Louisiana, just for getting around small places in still water and things like that. It's a really simple little boat, but I think drawing it will show the basics of how I design and build boats that I 3D print. So if you're not familiar with the boats that I've done, you should go follow me on Instagram. I post stuff about them all the time. It's my latest session where I do a lot of tugboats, from the pusher type towboats, or river tugs, whatever you want to call them, to harbor tugs, and just all kinds of different types. So let's get started on this pirogue. We're going to start off on the right plane, and in this videos, my goals are to teach you how to do, the really basics like a SolidWorks sketch. We like the right plane, and I normally start on the right plane because that's the view that I'm going to use the most, basically, and do some basic sketching there. But we'll also get into defining splines and how I like to define them, and doing relations on, different sketches on different planes, creating reference planes, and then getting into some surfacing features. I use surfacing features for just about every hull that I design, unless I'm specifically designing a sheet metal hull. So it's a really handy and powerful feature set, and we're going to learn a little bit more about it. So as you can see, I've put a pair of construction lines here, and those are going to kind of drive a lot of this boat design. This is going to be the height of my sides, which is going to be 12 inches. And this is going to represent my total length, but this line is only half the length of the boat. So I want to grab this point and grab that line, and since it's a construction line, whenever I move my dimension to the opposite side of the line, you can see that it doubles the length. This is handy if you're doing like revolves and things like that to create a diameter out of a radius, but it's also, if you're creating symmetrical parts, it's a really handy thing. So this is going to be a 12-foot long pirogue, so 144 inches. And we're going to draw this at full scale, and we'll scale it later. It's just easiest to draw something like this in full scale. Although my boats, I do tend to draw at scale for the larger boats. So from here, we're going to go ahead and insert a spline, and this is going to represent our shear. And we're going to start from this point. And since this is a really simple and symmetrical design, we're going to just use a 3-point spline. We're going to add a constraint here of these 2 points and this construction line to be symmetric. And now you can see that no matter where we move that, it stays even. And for this line, for this point rather, go ahead and make those coincident. And this point should also be vertical to this point, because remember, this is going to be the length of our boat. It's also kind of a nominal length, so you don't have to stick to it too hard. Okay, so with those constraints in place, the only thing we need to do to finish defining this spline is to put basically the camber of the shear that we want in this hull. And I like this 4-inch mark here. I think that that's going to be a really good looking hull. So now we want to add, this is going to be the bow and stern. And there's two things we can do here. We can either put the stem here. I guess you can, both sides technically have a stem. We could do a flat bottom, a true flat bottom, but most pirogues are actually, the bottom kind of follows the shear. Most wooden pirogues, I should say. Many of the aluminum ones actually have little rakes at each end and are truly flat across the bottom. But we are not designing an aluminum one today. We're going to add that symmetric again, which is going to allow us to define this. Now we could define this stem as an angle against this construction line, but I would prefer to actually define it as a value coming back from the point of the bow. Let's try that at 4 inches as well. Normally they are fairly sharp, fairly almost nearly vertical in the stem. Not sure what the technical term of that is, but it works. And we'll also add a value here. We can alter this value to whatever we want. We can put it as 12. So in other words, if you were just ripping a 12-inch sheet of plywood, but I don't like that look. I actually kind of like it if we were to go, let's try maybe 15. I think 15 is too much. It does take a little bit of practice or getting used to knowing how this is going to translate into the shape of a hull. So just bear with me and you'll kind of see how that becomes a hull later on. No, I think we should go a little bit more. That looks much better. And since, once again, symmetry is our friend, we can select the stem and this construction line and we can mirror entities. And now we have a fully defined sketch. Sorry. Now this sketch is going to play a very important role in the overall design of the boat, as it's going to drive basically what the boat will look like from the side. If you were to cut the boat directly down the middle, parallel to the keel or along the keel line, this is what we would actually be looking at. So this is a very important sketch. Okay, so from here, I think that we want to go ahead and add a reference plane. And we could have actually created this sketch to where we didn't need to produce this plane, where the top plane would have actually been what we needed. But I think it's actually more beneficial to show you how to create a reference plane and why we're creating a plane in this location. So you can see I've selected this point, which represents the topmost part of the boat. This is as high as the boat is going to be. And I've selected the top plane here, and it automatically gave us a parallel constraint, which is excellent. That's exactly what we need. We could have did a vertical, and you can see that it doesn't like it at all. But parallel to the top plane is exactly what we want in this case. And then we'll click check. And we want to create another sketch on here. So much like this sketch 1 represents a right-hand view of the boat, this is going to represent a top view of the boat. Okay, so to start off this sketch, we're actually going to add a pair of construction lines, much like we did in the first case. For this one, I'm just going to add from the very stem, top of the point of the bow, and I'm going to make those coincident. And the same thing on the stern. I will be using bow and stern kind of interchangeably on this boat since it is a double ender. So just whatever I say, whether it be bow or stern, just know that I'm talking about the ends of the boat. Okay. So with that construction line in place and fully defined, we will add another one, and this is going to come from the midpoint, and this is going to drive the overall width of the boat. So we'll select this point, we'll select that construction line, and these boats are extremely narrow. They're made like that to where if you're in, like, say, a cypress swamp where the trees are very close together, you want a narrow boat to be able to go in between and get through tight spaces. So we're going to make this 24 inches overall on the bottom. That looks extremely narrow. This is actually going to be the top, I'm sorry. This is going to be the width of the top. So, let's make it 30. How about that? And we're going to add another spline. Now, the benefit of this spline is that it's already going to be fully defined just as soon as we do that. So this is actually going to be the shape of basically a half hull, and that sketch is done. Now we need to add one more sketch, and that sketch is going to be on the front plane, which is the center of this boat, right at amidships. And this is what I call a frame sketch or a loft sketch. This is going to determine basically the flare of the sides, and also if you're going to have a V-bottom, you can determine the dead rise here. Since these are flat bottom boats, we're going to make this horizontal, but you could very easily add that dead rise in there if you'd like. And then we're going to add the flare of the sides, which we're going to make that 3 inches, I think, which will make our bottom 24, so this should be 12, a little bit more than 24, it's not bad. The reason we're kind of running into that is because you can see we're actually 16 inches here, but we'll fix that in a later operation. And we also need to go in and to fully define this sketch, we need to add a coincidence constraint there. And we can exit. Now, these three sketches are extremely important for the design of the boat. And best practice for me, this is a personal preference, is that I do not touch these sketches again as far as putting them into a feature. So these sketches will not be absorbed into any features. They'll be referenced to plenty of times, but they will always be right here at the top of my feature tree, so that anytime I feel like I need to go and change the shape or dimension of the boat, I know that I can grab these three sketches and do it. Okay, so now that we have the main sketches that are going to determine the shape of the boat, we can add one more sketch. And this will actually be a 3D sketch, and it's going to be a single spline in this case. And that spline is going to be defined by 3 points. This point on the bow, and this lower point where the frame is on the bottom side of it, and then this point on the stern. And that's it. Now the importance of this sketch is that it is what I like to call a chine sketch. So whenever this piece of material, whether it be aluminum or plywood or whatever, comes down, it will terminate at this edge, and then there'll be another piece of material which will start at that edge and come down. So that's going to make that chine section, hence chine sketch. And that's all that sketch needs. So hopefully at this point you can start to see the real shape of the boat and how it's going to kind of come out. And we're also to the point where, how we talked about before, these sketches are not going to be absorbed in any features. we're going to create kind of our first branch from that. So we need to grab this plane and create a sketch. And then we're going to use convert entities to grab just this spline curve here and check it off and then exit sketch. And then we'll actually go and hide this sketch too, because it can get a little confusing. It's going to disappear and you won't see that construction line anymore. And at this point, we can actually start doing our surfacing. So we're going to go ahead and create the side of the boat now with lofted surface. And our profile is going to be the sketch we just made and this 3D sketch. You can see that we're not getting a preview, and that's because these two green dots, which kind of set the guide, if you're not using a guide curve, it kind of sets how SolidWorks tries to extrapolate the surface. We want those lined up here, and that gives us a good preview. Sometimes it's really hard to actually work those into place if you have a bunch of entities that it can grab, but in this case it's really simple. We will add a guide curve in this case, which is going to be this sketch, and that's just going to keep it a little bit truer to being a flat side. You won't see any convexity or concavity, if those are words, in the side. Right, so now we can see the side of the boat. So now we need to create the bottom. And to create the bottom, we're actually going to add another sketch. We're going to convert entities again. We're going to convert the spline, which is the bottom of the boat. Exit sketch. Go ahead and hide sketch 1. And then we need to dig back in here because we need to see our 3D sketch and our sketch 3. And I know that it seems like I'm kind of breaking this rule by using this frame sketch as absorbing it into a feature, but in more complicated boats, you'll see kind of why I do that. It avoids having, something along the lines of 50 sketches just to define a hull where you may only need 15 or 20. All right, so let's go ahead and add this lofted surface again. And we'll click our chine sketch and our heel sketch, for lack of a better term. You can see that it immediately defined itself perfectly. We'll use this same frame sketch as a guide curve. And there we have it. So before we move on to cutting the shear, because right now you can see that we have no shear, it's just a straight line all the way across. I believe we can go ahead and mirror, give ourselves an entire hull. So we're going to click mirror. The reference plane will be the right plane because that is the keel line of our boat. Make sure that you are in bodies to mirror. Surfaces are considered surface bodies, and so you can actually see that here. And so SolidWorks wants to see those being mirrored as a body. They won't do it as a feature or they may do it as a face, but more than likely not. In options here, we want to make sure we knit surfaces, and that's going to knit this seam and the seams at the stem and the stern. Guys, I'm sorry, I'm not used to talking like this, so yes, apologies. So now we can see that we have two surface bodies. We want to knit those surface bodies together. So we'll go to knit surface. We'll select those two surface bodies and then check that off. So now you can see that we have this as a single surface body, and hopefully SolidWorks will allow us to thicken this. And I don't know how thick we ought to make this. I know normally they use like 1/2 inch plywood, so we'll do 0.5. So now you can see that we have a good thick, this is no longer just a surface, this is actually a a tangible piece of material. It's a half-inch thick. So now we need to pull up our sketch 1 again because we're going to move on to the shear. So in order to create the shear, we will go into our right plane again, sketch, and we're going to convert that shear line. And I think in this case, we're going to add a construction line, and we'll define that by grabbing the 2 points at the ends of this converted spline. There's a construction line, correct? And then we'll select that construction line, offset entities, and it's trying to select the chain, so do not select chain. We only need this one entity. And we'll offset it a lot just to make it easier to see things. So we need to reverse that. And we're going to cap ends with lines. And we'll check. So you can see that that created a raised line, so we won't have to worry about it for some reason not cutting all the way across whenever we do our surface, our extruded cut, which we're ready to do. So extruded cut through all both. And you can see that that made a nice little cut there. Go ahead and hide that sketch because it is no longer required. And you can see that this is a definite boat shape. So I think the next thing I want to move on to is we'll actually put a stem and a stern in there. And the way that we're going to do that is to use 3D sketches. Because if you look right here, we have just a single line from those surfaces merging. So we can convert that. And we can also convert that. And exit sketch. Now, there's a few options we have here. We can do a swept boss base where we draw up a sketch and project it along here. But I want to do something a little bit different. We're actually going to go into weldment, structural member, and we're going to see if I have a flat bar that'll work. And I don't. So let's go and learn a new thing. We'll create a new part, and we'll make a sketch on the front plane. And this will be the stem of the boat. So we're going to make this 1 inch by, I don't know, let's say 2 inch. Alright, so that's a fully defined sketch, and we want to add one more little thing here. We want to add a point. And I'm thinking that that point should be ¾ of an inch. And this is going to come in handy later. So exit sketch. Make sure that the sketch is highlighted in blue. And we will save as library feature part. And you can see that for some reason SolidWorks tries to bring us into the design library. This is not where this belongs. We need to go all the way into our C, program files, SolidWorks Corp, SolidWorks, and language, English, and weldment profiles. And then we're going to put this in ANSI inch in flat bar. And whenever I'm naming things, I like to try to follow a format similar to what already exists. So this is a 1 inch by, excuse me, 2 inch. can see that with this L on this sketch and the references and dimensions, that this is now a library feature part. More properly for us, it's a weldment. So let's go back into structural members, flat bar. There's our 1x2, and we'll select groups. We'll select this line, and now you can see that we have this point here, and we're going to use this point to locate profile, grab that point, and I think that that looks just a little bit better. So, yeah, that is very nice. And then we may end up having to add a new group here. Let's see. Yeah. New group, grab that line, same deal, locate profile. Actually, make sure that they're the same. Sorry if I'm making y'all seasick. And check that off. Okay, so I think it's time to do something extremely important that I often forget, and that is save early, save often. And I haven't saved at all. But we're only a half hour into this, so that's not too bad. We're just going to drop this on our desktop, and we're going to call it a 0 and save it. Now we all feel a lot better. Okay, so now that we have the material in place for the stem and the stern, we want to clean it up because you can see that it doesn't look very nice on there. And so I think in order to do that, we will select this plane here. We'll go back into our weldment, and we'll choose trim extend. And you can see that since we already had that plane selected, that drops it right into trimming boundary. Bodies to be trimmed will be this one and this one. And we want to make sure that we're keeping the lower part, discarding the upper. And that also we have allow extension selected so that it can pull this piece up. And check that off. So that looks much better. Now in order to fix this bottom section, that's a little bit trickier. So I think what we'll need to do here is to show our sketch 1, and we'll create another sketch, and we'll use it as a reference. So we should be able to convert this bottom, and then we'll add a line here, and then we'll make this line tangent, and we just need the length to be arbitrary. This is actually, we don't even need to do that. We can do like this. We can grab this endpoint, and we can make this vertical just as a constraint. And this is just to fully define this because it's going to bother me if it's not. And then we'll convert this to construction. And with that fully defined, it should be everything we need. There is something else we could have done differently, and we may do that. Alright, so reference geometry, plane, we grab this line, and we'll grab our right plane as a second reference. We are fully defined and happy. So we trim extend again. We already have that plane selected. We're only going to select this body this time. And let's see here. That looks much better, but I'm not entirely happy with it. So let's roll back. And we'll actually edit the sketch because I think it'll be better to do this in a sketch. Offset. We're only going to offset it a ½ inch because that's the thickness of our bottom. But we won't cap the ends. And then we'll select this plane and we'll edit. And rather than selecting this line, we're going to select this line. And check. And then we should be able to roll back up to here. And that, I like that. I think that looks a little better. I don't know. I think I liked it better the other way. Now we're going to see a problem here, but that's okay. Continue, ignore errors. We can go in and fix this plane because we got rid of the line that it was referencing, so it's very unhappy. But we can come back in and re-reference this line. And there we have it. So now that we've learned the power of rolling back and going in and editing features, we're going to go in and we're going to edit this feature again. We're actually going to get rid of group 2 because I think that now that we're getting, oops, I got rid of the wrong group. So undo. Undo is also very powerful. We're going to edit feature and we're going to get rid of group 1. Okay. And we're going to fix this trim extend because remember we just got rid of this body over here. But if we just drop back into this trim extend and check it, it automatically kind of fixes itself. So now let's work on this a little bit more and get it where we want it at. So we want to put a fillet on the top here. And we want to put a pretty generous one. I'd say about an inch. And let's see how one would look on the bottom. I like that. And then last, no, we'll put a smaller one on the back side here. Ooh, we're going to have to fix that point. That's going to be a fun one. Alright, so we'll add a small fillet here. Really small, something like 0.3. That's just a little bit. Look. Now, how are we going to fix this? We're going to use another surface tool. We use offset surface. And the great thing about an offset surface is, you see how my value is already 0 here? That doesn't make an offset surface. That actually copies the surface. We want to copy this surface. And then we'll use that surface since we have it selected here. And we want to do cut with surface. And we want to select bodies. And we're going to select our actual hull. And I want to say this arrow, we need to flip it because that's going to be the direction of our cut. It's going to cut it out this way rather than in this way. And there we have it. You can see a little tiny bit of it, but it's literally coincidence with this surface. That's just kind of a little SolidWorks visual thing. Go ahead and save it again. And I want to add one more feature here before I mirror this over to the stern. And that feature is going to be something to tie off to. Pretty important. So we can do that either on the right plane, but in this case, you know what? No, let's do it on the right plane because if we ever go and change this, I want to make sure that this is defined in an area. Yep, I want to make sure that the sketch is defined in a place where we can't get rid of it, basically. Where no matter what we do, if we remove this entire thing, that feature will still be grounded in some geometry that is not going to go away. I really hope that made sense. Alright, so I'm thinking something around here. We can make it coincident to that line. There he is. And we can actually use this sketch 1 as a, reference basically for everything. Make that 2 inches down possibly. And that seems a little small actually. I normally would like to see a 3/4 inch hole there. So let's get rid of this coincidence. And we'll just move this away. About Let's do that. That looks much better. And then we will through all both. We want to make sure that we're going through all bodies, which auto select is going to select that for us. And there we go. Now we have a place to tie our boat off. That's handy. If you ever let go of a boat in a river, it's handy to have a place to tie it up too. Okay, so I'll keep on changing my mind. I want to add a fillet to these edges, kind of like if you would router the edge of these edges, but I don't want it to go all the way around because I don't want this back edge here to be round. So let's turn off tangent propagation. It means we have to do a lot of manual selection, and it may not even allow us to do that. Okay, so it won't. So let's try something different here. Let's reduce this to 1/8. Turn tangent propagation back on. And then just kind of visually look and see what that's going to look like. I think that would be okay. Yeah, I think just visually that works. Next, I think I want to add a couple of seats. So to do that, we're actually going to go all the way back to our sketch 1. And we're going to figure out our seat placements by drawing some lines. I think we'll have one here, and we will have one opposite. And then I think we'll have one directly in the middle. And they're all going to be the same length. So we'll control and select all of them and pick equal. And we'll define this as, oh, that's perfect, 8 inches. And then I think what we'll do is we'll use this line to kind of define where we want them at. Actually, you know what? I think we use this point, which is the same to say that line. I think 5 inches is a good height. This one will be a little bit shorter because the way that the shear comes up, it'll actually be a little bit higher technically. I'm sorry. Let's make that 3.5. And then from the end of the boat to this edge of the seat, we want it to be, I think 12 inches would be better. Let's grab our right plane again because remember, we don't use this sketch for anything except referencing. We'll drop into another sketch. We will convert entities. We'll convert these 3 lines. Check. And then we'll go into features and we'll do extruded boss face. And you can see it automatically pulled us into thin feature, which is really helpful. And we will go through all is not going to work. Let's go, I think up the surface may work. Yeah. And we'll do the same thing for direction 2, up the surface here. And you can see that it's making some little planks. And we need to make these thicker. We're going to make these 3/4 inch thick. And we'll reverse the direction because we want them to go down rather than up. Which, oh, look, this one's a little bit of a rebel. So we're going to have to select these contours. Let's see if it'll do it if we select it manually. It won't. That's okay. And we're not going to merge result at this point because of the way that this one acted. We could have, but we're not going to do it. Something different in a minute. Okay, so now, once again, symmetry being our friend, we'll select front plane, and we'll select mirror, and since we didn't merge this body, we can mirror that, and that's going to add the seat on this side, and we can mirror this body, and that's going to add the stem on that side, and it's going to bring in all of those features in one simple, clean little package. And there we have it. This is pretty much a pirogue. Hide. Let's go ahead and save again. Oh, there's one thing that we do need to go and do again, though. Do this. Okay, so we do need to actually go in and add another feature because the hole in the stem does not transfer through to the other side of the hull. I think we can actually do that through another mirror if we want, or we can do it through another extruded cut. We're going to try a mirror. We're going to mirror a feature this time. We're going to grab that extruded cut. And we're going to apply it to just this body, just in case it wants to try to make a error with the stem part. I don't like this color green. We'll fix that in a minute. Really quickly though, we want to come and combine all of these bodies that we didn't merge. And hopefully SolidWorks allows us to do it. Sometimes it can be a little iffy, but there we go. So we'll check. We still have two bodies. Why do we have two bodies? Surface. Oh, these are surface bodies, so those don't matter. But we can see in our cut list item there's only one body. That's great because we're planning on 3D printing this, so it needs to be a single body. Alright, let's go and fix this green. This is like, I don't know if I'm allowed to, this is like a John Deere green, and that is not the color that most heroes are painted. They actually painted a camo. So we're going to edit this appearance. And if we go down here, these values are the RGB values. Alright, so we can do something really cool with that RGB value. We can pull up a Google Chrome tab and we can Google RGB values of, what is it called? Oh, something like that. Camouflage green, okay? So, pull this up. And we can see on the RGB color chart, because it's 47, 53, 42, and I like that color. I can deal with that. Let's move this over. And we'll come right here and we'll just type those in. So 47, 53, 42. I think it's just my computer that makes it look like that. So we can go and, let's save it. SolidWorks add-in, and let's do a render on this. Without camera perspective. It's going to take a second to load up. Oh yeah, so that green is there. I don't know if you can hear that beeping. That is my battery backup on my computer actually being very angry over the work that I'm asking the computer to do. Alright, so to move on to 3D printing, we're going to save as... actually, no, before we do that, let's go in and scale this because remember right now it's 12 feet long. So if we pull that in a 3D printing slicer, it's not going to be happy. So uniform scaling, and let's bring it down to 1, divided by 128 is 0.0078. So let's see if it'll let us do 0.008. I don't think it lets us put on it. I'm sorry. Of course, the one body that exists is going on the scale. Alright, let me see, hide these. And then if we zoom way in, look at that. We got a little bitty scale model pirogue. We can save as. We're going to save this as an STL because we're going to resin print this, and for my printer, it prefers STLs in the slicer. It won't bring in AMF, which sucks. Anycubic, get on that please. Selected bodies rather than all bodies, because I don't want it to bring those surfaces in and trick me. And that's it. It is saved as an STL. Alright guys, I hope you enjoyed this video. We will move on into doing the more complicated things like the tugboats in a later video. I just wanted to get this one down because I think it shows a lot of really important building blocks. The principles are essentially the same from boat to boat, but the complexity comes in with the geometry of the hull. So I'm hoping that this is going to be a fairly short video while still being pretty comprehensive, and I really hope that people learn something. So thanks for watching, and I will see y'all next time.